Hello and welcome to Inside Modular, the podcast of commercial modular construction, brought to you by the Modular Building Institute. With a compact footprint, variety of unit options, and seamless system management, City multi-variable refrigerant flow zoning systems from Mitsubishi Electric Trane HVAC US are a one-stop solution for modular projects. With efficient operation and the ability to connect to commercial ventilation equipment, third-party systems, and comprehensive control solutions, City Multi VRF can help you meet energy and performance goals on your next project. From off-site development to on-site assembly, you can trust our manufacturer-level support to guide you from system selection to design to startup, no matter the application. To learn more about our offerings, visit MitsubishiPro.com. Welcome everyone, my name is John McMullen and I'm the Marketing Director here at MBI. Today I'm joined by Brent McPhail of Brave Control Solutions. Brent is here to talk more about the potential of automation in the construction industry and how it specifically could benefit the modular construction industry. Brent, welcome back to the podcast.
Thank you, John. I'm glad to be back.
For those who did not hear our previous conversation, tell me briefly about yourself and about Brave Control Solutions.
Sure. So at a high level, I own a company called Brave Control Solutions, and we develop automated solutions for manufacturers. And so historically, we've built a lot of equipment for the automotive industry for manufacturing, as well as some food and beverage and general industry. About 3 years ago, we started to make a pivot towards automating for construction. And as anybody who's listened to this podcast already knows, it's the next wave of the future for the modular and offsite construction industry. And so we've developed a number of solutions and systems for the offsite construction market.
So the last time we spoke, we talked about automation in general and the obvious potential benefits for modular construction, but there's significant challenges to automation, especially for buildings, right?
Yeah, so briefly, I guess what the previous podcast sort of focused on was what we called Snowflake Manufacturing. And so from our experience in traditional automating for manufacturers and then into construction automation, one of the things that we learned early was this quick little analogy I talked about, which is the F-150 story, which is, the F-150 is a very complicated piece of equipment. However, you would never build a factory to build 1 million of those F-150s without knowing each and every component that's going to go into that F-150. Mm-hmm. Well, when you look at the construction industry and what we call Snowflake Manufacturing is before your first factory is built, you've already designed a new building to run in that factory. And so while there's a lot of parallels between the two industries, there's some unique and significant challenges with offsite construction that we've got to address specifically.
So what are some of the specific hurdles that you as an automation company face with construction projects?
So a specific hurdle would be the flexibility challenge. So because of the nature of the way that we build these snowflakes, we have to build automation that's able to react as quickly as the consumer demand reacts. So as a new building comes in, as an architect has designed a new type of building, we need to make sure that we can, leverage as many tools as we can to sort of change our fixturing and have our robotic systems able to adapt to handle that flexibility. And so one of the things that we want to talk about today is this term that gets thrown around, which is design for manufacturing. And so, I hear design for manufacturing, but when you want to design for automated manufacturing, it adds an even additional layer to a subject that architects are already sort of struggling with in the modular industry right now.
Mm-hmm. So what ideas do you have to help design and automation sort of meet in the middle?
Basically, in a perfect situation, what we would do is we would adopt the off-site construction industry to make everything exactly the same. So there would be no variability. Every building would be the same. And then we could use our traditional automation methodologies that we use for, say, making cars. Of course, that's not possible. Mm-hmm. So then the other side is the construction industry would come to me and say, Brent, we need you to make a machine that is 100% flexible, like a Star Trek replicator that can make anything that we demand. That's far off in the future. And so that's also not possible. So in order for us to meet in the middle, we've got to sort of find that area where there is enough flexibility in the product that the consumers will buy it and that the architects can continue to build it, but also that there's not so much flexibility that we can design automated systems to work in that environment.
Gotcha. So it sounds like there really needs to be a change in thinking, maybe for design professionals, architects in particular. What suggestions do you have?
Yeah, so what I would say is that the challenge that I see coming down the road is that when I hear this term of design for manufacturing thrown around, I think that what's happening right now is architects that are working in the modular industry, they're savvy to this, and they're smart people. And so what they're doing is they're now going down to the floor and they're asking the framer or the welder, hey, this last project I designed, why are you guys putting more hours into assembling it? And so one advantage they have is that guy, that human, he is incredibly flexible and he's incredibly resilient. So if they don't do the best job of designing for the manufacturing process, they can still accomplish that process. It just, makes somebody's job a little bit worse. And so that's kind of the situation that we're at right now. The humans have the flexibility to pick up the slack. The architects have the time to start to learn what they need to do to help in that design for manufacturing. Well, when we move to the next step, which is designing for automated manufacturing, robots are incredibly flexible, but they are not very adaptable on the fly in situations. Right. And so if we don't consider the design for manufacturing of that robotic cell at that time, we have to then bring in humans to make up the slack for the robots are. And so if you can imagine the investment that a company has made in putting robots in a system and then to have to go back and use a human to basically pick up the slack because that robot doesn't have that adaptability on the fly, there's a lot of frustration there. And so us as robotic designers, what we are trying to push and what we're trying to say is, okay, guys, but if you work with the robotic designer to help create the envelope of what needs to be the flexible requirements for your system, then you have something that you can design within those parameters to be able to get the best out of your automated system. And so it's a lot smoother, but it takes a lot of conversation at the beginning.
It sounds like it. What would be the process for implementing these sorts of changes in the short term?
So what we've been doing is we my company specifically, we go through this solutioning process where we define the requirements. And so what that means and what this is driven by is that, there's a lot of smart people, architects specifically, that are making really bad choices right now. And so the question you have to ask is, why would a smart person who certainly doesn't want to make his job harder or anyone else in his organization's job harder make a bad choice? And the reason is because they can't see it. So when you think about, traditional automotive manufacturing, there's nobody that, you're not designing a car to work in a factory that's never been done before. Even when Elon Musk is making his factories, he's still using techniques that have been around for 50, 60 years of automation. So you've got this designer who is in the automotive industry, who comes in and he knows that in order for him to get every the parts located and all the gaps and everything correct, there's a whole bunch of detailed work that happens behind the scenes, behind the door panel. If you peel that door panel off, you see all kinds of locating pins and holes and things for the robots to grip onto. Well, architects don't see that because that's not their past and because we don't have a pre-existing system to show them that. So what we do is we try to get the details required for the project at the high level. And so the mins and the maxes, some of the basically the business rules or the design rules. That's the starting point. And then what happens is we have to then make a concept of a machine at a very high level that we can put into a digital twin or digital model so that we can simulate so that the architect can now give us better feedback as we're designing this machine. Once that machine has been agreed upon to work within the parameters that are given, then what happens is the architect has the ability now to see it. He has the ability to do a design, to put it in this virtual environment and try it and test it and see where the robot's limitations are. See where, a limitation of a robot, for example, would be a reach. So you've decided that you want to put two structures a few inches apart. Well, a robot might be 1.5 feet wide. And so if it can't reach inside that area, it can't perform that task. And so then that means that automated system is going to be, instead of 100% completely automated, it's going to have some manual intervention component. Well, if you can't see that and you can't visualize that, you can't make a better design choice. And what we're finding is that the architects look at it and they say, well, I don't have to put that structural piece there. I could put it over here and it would have the same effect from what I'm trying to achieve. But from the automation side, it then gives them another piece of that puzzle that can be more fully automated. So giving them that environment, and it is early stages. So it's sort of, the opposite of a good design, really. But it's where we're at right now because of this early nature is we give them the ability to trial and error their design in a virtual environment instead of trial and erroring it on the actual floor. there's ways we can do it better in the future, but this is the stage that we're at right now that we're finding is working quite successfully.
And what's that process been like communicating with architects that you've been with? Have they enjoyed this process? Have they looked at this product and said, hey, there's a lot of potential here? What's the feedback that you've gotten so far?
Yeah, so generally what happens is they know the challenge, they know the problem, and we all know that it's happening right now, and we don't have generations to wait for this, right? We can't pass this travel knowledge down. So they know the problem. Generally, what's happened is there's a lack of communication because the manufacturing guys are sitting apart from the architecture guys, which are sitting apart from the automation guys. So what we're really pushing for is to have that conversation up front. The way it's been happening now is the manufacturing guys guide and direct us on how to make that machine, that first step of the process, the mins and the maximums. And the architects aren't necessarily involved in that. And so then what happens is when the architects do get involved, they don't realize the limitations of the machine, and so they're busy doing their designs, and so we end up with a machine that's capable of running, say, 80%, 70% automated, and the rest has to be done off-site. Well, then that'll facilitate the meeting with the architect. The architect will then sit down and say, well, if you guys had to show me these rules ahead of time, then I would have been able to, make better design choices. And so as they go into their next project the quality of the quantity and the quality of how much they can automate goes up. So that's been historically what we've been sort of seeing so far. What our push right now is now that we're aware of this, is to just get everybody in the room that needs to be in that room up front so that they can see what's going on, so that we can show them how to use the tools, and so that they can start off making their designs better. But to be honest, there's an active business case that's going on where a lot of times when we get involved, a building has been sold. It's already partially designed, and then people are trying to scramble to manufacture it. So, it's not that I don't feel that people aren't doing it wrong. It's some of it that they don't know, and some of it is just market-driven, business-driven, like everything's working in parallel instead of, nobody has time to line everything up in a perfect order. So it's just an iterative process that we go through.
So I asked you about the implementing these changes in the short term. So what's on the flip side, what's the ideal that you guys are striving for? What's the long-term solution?
Well, so the long-term solution is a couple of different things. First of all, as we learn and as we keep developing applications, we are able to make our robots do more and more and more things, right? So it's still very early days. So in the longer-term solution, there will be less limitations. But I really don't see a point where we eliminate all the limitations. So the part that I would like to change, I guess, in sort of a longer term as we get through this is that instead of us giving the architect a sandbox that he can try his design and see if it passes or fails, we need to integrate with the data systems, with the BIM models. We need to integrate with sort of the tools that they're using to make their design decisions the same way that they would, from a cost point or a bill of materials point. We need to build in the design limitations of the automated system at that point. Now, the reason that's such a long way away is the same as we're at right now. It's just there's a lot of balls up in the air, and that's a lot of integrated work. So we believe we've got a short-term solution right now that's a visual tool that'll help the architects design better once it's been established. But I believe the long-term has to be, how do we not even need that tool? How do we just limit his choices at design time so that they work with the automation?
So here's a fun thought experiment. We've had the benefit of seeing lots of other industries evolve into automation over the past century. You brought up automobiles, and we're just getting to the point now where we're automating building construction. So tell me about modular construction in 50 years. How does that work?
Yeah, so 50 years from now is going to be almost impossible for me to predict, because I think the rate of change of our technology it's exponential. But it is an interesting question. And so I can talk about where I can see sort of this, the modular going. And what I would say is that what I found is with, technological innovations, we always tend to overestimate in the short term what their impact is going to be. But then I believe we underestimate in the long term of what their impact is going to be. And so, I believe that Brave is a front runner in developing some of this technology. But I know that we're not alone, and I know that as the market demands it, there'll be more companies like Brave in the next 3 to 5 years that are jumping in with their own version of their CAD to Fab product or their, digital twin design tools. So what's going to start to happen is we're going to see a lot of changes really quickly. What I believe is that in traditional manufacturing, there's a movement to start to go towards a decentralized model. And so what the modular construction industry is doing right now is they're sort of following the path of traditional manufacturing, which is a centralized model, big factories pumping out product and then shipping the product. And, there's always a debate of, 3D volumetric versus 2D. Do you ship air? Do you not ship air? But I think what's going to happen is that debate is going to start to change. And as you see people that are putting up, 500, 1,000, 2,000 house subdivisions, and then they move, after a year or two to the next site and they do the same thing over and over again, that there's going to be a demand for a more mobile modular factory that not only provides flexibility in the products that it can produce, but it provides flexibility in where it can be established. And so I have this vision of transport trucks that are flatbeds that we connect together that have a structure that forms sort of our factory bed, and we input raw materials into those transport trucks, and then we spit out the products that we want, right localized at the job site. So that's kind of and to put a time on that, I mean, we have the technology to do that right now. I don't know that we don't have the market for it. But I think as housing costs go up and labor shortages increase, that changes the game. So we could be 3, 5, 10 years out as we're starting to build these type of applications in a more decentralized manner.
Well, I love that idea of the mobile factory. I know some of our other members rent spaces. They don't have a centralized factory. They rent buildings. They create modules close to the job site. But I really like the idea of one that you put on truck beds and you take wherever you need it. I'll be honest, though, I was kind of hoping you'd tell me in 50 years we'd have Star Trek replicators, because I'm really looking forward to it.
Well, we will, but it's hard to sort of quantify that, and it's certainly hard for people to understand it. But when I talk about, like, it's sort of in our traditional manufacturing discussion, there's been some talk that in this decentralized model, what you're going to end up with is a factory where you just input raw materials. Mm-hmm. And so those raw materials, whether you're, using 3D printing technologies, and that 3D printing, in a lot of ways, our 3D volumetric machine is it actually just a 3D printer. It just doesn't use the traditional, melted wire or lasers to form the alloys together. It basically just uses, a methodology where it takes the CAD data, assembles its fixture, assembles the product, and then fastens it together using other robots. So in a way, that is a very, 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 very crude Star Trek replicator.
It is.
As we get more advanced and we start to say, okay, we're going to put glass into this factory, we're going to put wood into this factory, we're going to put steel into this factory, and we're going to start making windows and structures and these other things, but it's just sort of like a raw materials in and a product out. But we're obviously a ways away from that. But I think that's the future of manufacturing, broadly speaking. So.
I love it. Maybe one day we'll get some Earl Grey tea hot with it. All my Star Trek friends will get that one.
Yeah, exactly.
So what do design professionals and manufacturers need to do today to prepare for this future that is rapidly coming upon us?
Yeah, so actually we did touch on it a little bit, where I think we need to sort of bring the parties together sooner. So mm-hmm. There's certainly a more collaborative look that we want to have at the design of the machine, the design of the product. As I talk about the architects, they really, up until this point, have only really focused on, the aesthetics, the structural, the space utilization, the business case. But now there's this design for manufacturing component that they're working on with the modular side, and it's only going to get deeper as we have, we've got more restrictions with the robotic systems that are going to require more choices. So there's certainly a collaborative approach. The other thing I think that design professionals need to do is they need to accept that there is a paradigm shift. This is not a minor change in the way that we're building things. This is a major change. And so I think that it's easy for us to just say the words, yeah, we know it's going to change. We know that this is what's going to happen, and we're cool with it. But that's just words. Really, this is a monumental paradigm shift in the way that we are going to manufacture buildings. And so I don't know that there's really a call to action there, other than it's more of a buckle up your chin strap and get ready, because it's a big shift. It's a big change. And then I think just having an eagerness to be on the front of that wave, right? So there's a lot of frustration, a lot of pain, a lot of mistakes happen on the front of that wave, but there's a ton of excitement and a ton of opportunity there as well.
I think there's a tremendous amount of opportunity. It's just a matter of how we get there and how soon we get there. So tell me about what BCS is working on now and what's in the pipeline.
Yeah, so since we kind of got our feet wet in the 3D volumetric, we've continued to refine different fastening applications. So instead of just welding, we've now got an application that's doing some screwing, nailing, gluing. We're working on clinching, which is forming of metal, and some different types of welding techniques. So we're doing some application development there. We're doing some consulting with a number of clients that one thing we didn't touch on is that while design for manufacturing is kind of the current challenge we're facing, there's another challenge in manufacturing, which is what I call the manufacturing organizational structure. And so that's another topic maybe for a future podcast, but really quickly, that's just, manufacturing doesn't just happen. And so we've got to prepare our clients that you're not just building a construction job site under a roof. There's a complete different philosophy in the way that we manufacture within an organization. And so that's a different thing. But we're doing some consulting there. We've got an interesting machine right now that we're building, which is to do copper pipe cutting, processing, and fastening to help a plumbing contractor. So save them a lot of time with their kitting. And then the volumetric, we're working on some projects that's not necessarily 3D volumetric now, but using the same concept, the same sort of flexible, precision, automated fabrication methodology to work with cylindrical type of objects and 2D objects. So I mean, a lot has changed within Brave in the last 3.5 years, from not being involved in the construction industry to building systems for the construction industry to now, developing and innovating new types of systems to solve challenges that, we weren't even on our radar 3 years ago. So it's very, very exciting times for myself and my engineers.
It sounds like it. There's tons of potential there. We're excited to have you guys as members. Thanks so much, Brent. I really appreciate your time today.
Well, thank you very much. I appreciate your time as well. And, I love these podcasts because it's always a good time for me to even get my thoughts out that a lot of times are swimming around in my head. And so I have to sit down and organize it. So it's very enjoyable for me. Thank you.
Well, I look forward to talking to you again.
Okay.
All right. My name is John McMullen, and this has been another episode of Inside Modular, the podcast of commercial modular construction. Until next time.